Alright. What is this test for? Some Stogonometry test? Alright. Welcome back to another science cranking video. Today we're gonna go through balancing a chemical equation. Meh meh meh. Meh meh meh. But why do we even need to balance a chemical equation? It's actually pretty simple. If we don't balance our equations, then we all die. It's because we would break a fundamental rule of life, the law of conservation. The law of that matter cannot be destroyed nor created. This basically means we can't make something from nothing, or we can't turn something into nothing. Now that I've explained that, I'm going to walk you through something I barely even know how to do myself. Balancing an equation. The equation we are going to make balanced is on the screen. KC, L or I can't tell, and oxygen, yep. And then, yeah. Oh wait, I put it wrong. I think Cl's chloroform, maybe? I forgot. I never did pass the checkpoint. I still need to retake that. I know that this looks like a mess of like letters and numbers, but that's just a rumor, right? I'm going to be walking you through how to balance a chemical equation right now. It's actually very simple. It's very simple. It's so simple, I'm not even going to look at my script. So, okay, how did I do this again? KCl counts as one thing, so but also doesn't count as one thing. The K and Cl, they're clumped together, right? Like they're one thing, but they don't count as one. They count as two. It's a compound. That's what you call it. Okay, KCl is a compound. It's two elements, but they're clumped together, right? So you have to count them as one, but they count as two. To make it balanced, we need both. We need the KCl on both sides to be the same number. We need the oxygen on both sides to be the same number. But Corey, how do you know what number they are? Oh, I'm glad you asked. So you go like, so KCl, right? It's a compound. So you have K and then you have Cl, and it makes they count as two, right? And this right here has a little subscript. These are called subscripts, right? Subscripts, scripts. They're called subscripts, and which means that this is 3. And guess what? We can add, I forgot what it's called, but we can add little numbers. We can add, no, not little, big numbers to the front of each element. And that basically times it. So if I do this, this is times 2. This is 2 times 2, right? If I did this, it'd be 2 times 3, right? Keep that in mind. Keep that in mind. Retain that. Retain that. Are you the retainer? These aren't balanced. Yeah, this is 4 right here, and this is like 5, I think. It doesn't matter. We need KCl to be the same. KCl's easy, right? Because it's the same exact thing on the other side, right? So the solution to this side will be the same to the solution to this side. Oxygen is a little bit easy. No, it's different. And it's easy, though. I'll show you how it's easy. It's actually... It looks harder than it is, right? So KCl, since it's 2, right? These are both. What am I doing again? These two. Let's do 6. Let's make them both at 6, right? Each equation, chemical equation, has its own solution, and each of them also have solutions to. I think there is a way to do this with a different number, but we would have excess. KCl. We're gonna make this the same as this one, right? We're gonna make these both 6. Wanna know how? Well, guess what? This is 2. So wanna know what you do? Guess what? You add a 3. Wanna know why? Because 3 times 2 equals 6, I think. This is 6. Guess what? We don't even have to calculate this. Wanna know why? They're the same thing. So it's the same solution, right? So this is 6 now. Done. We already did half of it. We're already halfway through. Now, it's a little different here, but it's almost just as easy, right? So you see this 3? That means it's 3, right? And we're trying to get all of these elements, trying to get all of these at 6. We're making them balanced. So guess what? It's a 3 right here. How do you make 6? Now you have to do. All you have to do is add a 2. And guess what? It turns into a 6. Right? It's so easy. And guess what? Guess what? This is a 2. This is a 2. So wanna know what? Wanna know what? Remember what we did with KCl? KCl also has a value of 2 because it's a compound. You just add... What was it? You add 3. Boom. And then that turns into 6. Boom. It's balanced. You just did it. You did it. You did it. You balanced it. But Corey, why do we have to do all this balancing? Nothing would make sense if you could make something from nothing. Or destroy or turn something into nothing. You can't do that. Something is always something. 60, you could go like 64 G/mol. I think that's it. I think that's the method. Anyways, how to calculate it? It's easier than balancing equations, believe it or not, right? Calculate the molar mass of water, H2O, is to first look up hydrogen, which is H, in the periodic table. This is the atomic mass. But here's the secret. It's also the molar mass. Oh yeah. Is the 2 in front of the... Is there 2 oxygen or is there 2 hydrogen? Okay, yeah, there is 2 hydrogens. Okay, when I was doing this in one time, I was doing it wrong. There was not... Why I even... Okay, I wasn't thinking, but... I had the... My heart was in the right place. Okay, never mind. Oxygen is the one you keep the same. You see? In hydrogen, there's this little subscript right here. You know what that means? It's just like equations, where this means it would be 2, but instead of that, it means you times this hydrogen's atomic mass by 2. I don't have a calculator pulled up. 5, 6, right? Wanna know what you do with that? You're not done yet, buddy. You're almost done. You plus these together. And that's it. That's how you calculate molar mass. It's so easy. So easy. I think this is how you calculate molar mass. I could be completely wrong. Oh, yeah. Okay. I'm going to teach you about the importance of limiting excess. Right? So ponder me a scenario. Ponder. You are with your buddies and you're making s'mores by the campfire. Make it a little fancy at an inside flame, right? You and your buddies have a good old time. He's a little short, but that's fine. Oh, and 2 of you want a s'more. So you go up to your table. It's just like D&D, right? How I'm explaining to you. You make it, right? And then you make 2 of them to prepare for you and your friend because you want food, right? But then there's 1 more chocolate left. And you're like, man, it'd be really nice to have another piece of chocolate. But think about it. Don't do that. Wanna know why? Because if you add another chocolate and melt it, it's going to create excess chocolate on your s'more. And it's going to drip down on your hands. And it's not going to be a good time. Wanna know why? Because sticky hands are gross. And you're in a forest. It's over, pal. There's no river for 10 million miles. And that's okay. Because you're not going to do that. You're not going to have excess products in your s'more. You are going to use the select and correct amount to make your s'more That's what the importance of excess, I think. Take that message as you will. I don't feel like doing this, but it's like I'll explain it. I think this is what it is. When I was like looking at this, I was like, "What is this?" And then I was like, "Oh, does it mean this?" So I'm gonna tell you what I think it is, but this is probably wrong. I think it means what you have to do to use the absolute bare minimum of a product in an equation. Because you know in equations you go like 2 times 2 to like you remember how like we were making it 2 times 2 to make like 6 or something. If there was another equation where like you times it like by 8, right? To make it balanced, but you could have times it by 4 to make it balanced. It's still balanced, but it's excess, right? I think that's what the stoichiometric equation is. I think it's the metric to use the absolute bare minimum of a product to make something balanced. I think that's what it is. It's over, and I have to edit this 37-minute video down to 6 minutes. Okay.